Alright, so this is the webhook and particle code. So to do the webhook, you would come to set it up, you would go to the webhook section, and then you would put add new web integration, and then you would do, and then it would look like this. So add new integration, and then you would type in the name of your webhook, you can call whatever you want, and then what we have here is we're calling our event name temp, and then for the URL, it would be the same one as provided here. And then you want response type to post, request type goes, and response type. Request type is post, and then request format is JSON. And then the advanced settings, we put default here. Field one would be particle value. And then for this is important for enforce SSL, you would put new. Then once you have your code in your particle web IDE, then this, I'll explain what's going on here. So up top, we've got all our include statements. This is including all the libraries that we need for the device. Some of the important ones that you mentioned here are JSON. This is used to parse the JSON response from the server. And the SVO2 algorithm, this is how we are getting our readings from the sensor. This max05.h also helps with that as well. And then up top here, we can see all of our global variables. Those are used by for various functions. And then this function right here, this is used to get the time from the response from the server with our start and end time for taking readings. And then here we have the JSON, a debug variable for JSON data that I can use to make sure I'm parsing data correctly. That function or variable would be used with this right here. This is what's actually a variant of this is actually used right here. This is what actually is called by the response handler when there is a response from the webhook from the server. And this function right here, this is used to extract the epoch time, as the name implies. Because when we send a time to the server, we're sending an epoch time, and we need to send it. So as you can see, this is it takes in the data, and then goes to a string, and then it makes it finds the actual time in the string that we're sending to the server, so that we can check and make sure it's in the specified time. And then here in the setup function, this is where we set up the device and the webhook response, registering that. And then in the loop, this is where things really get interesting. So as you can see, our state machine here, we have, this is our wait state. This is when we're waiting to ask the user we're waiting before we ask the user to give us some data, a reading. Right now we have this commented out. This would normally be right for this, but for testing purposes, we had it that way. So this would wait the specified time between asking the user for measurements. And then this will make the LED blink blue when we're asking for measurements. There'll be a demo of that in this video as well. And then after we do that, once we get a reading from the user, then we transition, once we wait the specified amount of time, then we go to the read state. We can also go to the read state anytime in about 5 minutes while we're blinking blinking the ask the user for a reading. And then here, there's a lot of debug statements, but the main statement here, this is asking to make sure the time of day is not before the the start time and the end time, and make sure it's after the start time and before the end time, so that we're taking the readings in the right time. Because we don't want the user should be taking readings while they're it's super late at night. And then more debug statements, and then this is manually provided from the Spark Fun library. Takes a reading and does some averaging as well. And then this is where we check to make sure. This is my algorithm for making sure that the data is valid. So if we have, this is part of it. If the heart rate is within these values and we know it's a valid heart rate, then we store that intermediate value, and then we can also specify how accurate we want to be by this way, right? And then pardon me, actually this was right, this value right here, this specifies how many required accurate measurements we need. And then this is our string that we will send to the server when we have a accurate reading. This is checking to see if the Wi-Fi is on and connected. If it is, then we will send the data from the device. Well, we first check to see if there is any stored data in, which I'll get to later. And then it will send that first, and then it will send the reading, the most accurate reading that it just got here. And then if the device is not connected to the Wi-Fi, then the device will look and find an empty spot in its data storage bank, and it will store the data that it just recorded, the valid data, into the first slot that it finds. And then that's pretty much it. Once we're there, then we just reset, and then it's an ongoing, just a normal state machine from there. That's it for the web. That's it for the Particle Web IDE, which has the code for the IoT device.